So what are we doing this week? Let's keep on moving. It could have been a sled dog in normal life. This week I spent a bunch of time traveling and out of my weekly routine. So unfortunately, we're gonna have to do this week recap style. So what did I get done and what did I hope to do this week? Well, I started by refactoring the animation flipping that I made last week so that I can use it for both the main player and the enemy. Now to move on to enemy movement. Last week, the enemy didn't move anywhere on the screen. It stayed in a fixed location. This week, I've made it so that the enemy will follow the player around wherever it goes on the screen. It does this by taking the position of the player every frame and making that its next destination. Now, I don't use the move towards functionality. Instead, I made it a little bit more custom. That way we can use AI steering algorithms. I also spent some time this week playing some older brawler games. And I mean, not terribly. One's definitely older, which is River City Ransom. And the other one is, it's newer. It's probably, about 10 years old at this point. But it's been re-released, is Castle Crashers. And while I was playing Castle Crashers, I found something really interesting in the way their AI behaves. Instead of playing the game the way it's normally meant to be played, I decided to walk around with my shield up. Literally, here, I'll show you. And when you walk around with your shield up, the enemies, you can see how they behave. You can see at certain times when you have more than a few enemies on the screen, some of those enemies will actually just sporadically move around the screen. Granted, it's in a pattern, but they do move around the screen to make it seem like something more is happening, like there's more action going on, which is really neat. When you have your shield up, you'll see that sometimes enemies will jitter away from you, and that's because they're trying to stay a specific distance away from you at any given time. You'll also notice that when you eliminate an enemy, another enemy will possibly take its role. So each enemy has a different role. Like, you have the guys that randomly move around the screen, you have the main enemy that harasses you, and then you have some enemies that kind of just crowd around you. So I thought this was really neat, and it's definitely worth taking a look at games that are in your genre and just seeing how they've done things in the past. Also, you'll notice that there is no obstacle avoidance. And I found that really interesting because I played this game and I never knew it until I played it the way it wasn't meant to be played. But it works. Like, I played this whole game without ever knowing how this behaved, and it was a lot of fun. So there is something to be said for doing things the most simplistic route that you can. One, it'll save you a lot of time, and two, it'll save you a lot of complexity in the long run. So on the note of obstacle avoidance, I had hoped to actually implement that in my game. We're also going to look at making the enemy move and avoid obstacles. So that's what we've got in store. Unfortunately, that's a lot harder to do than you think it would be. In fact, I spent a full 2 days trying to do that. And it did not work out well. Like, at all. It was, it was horrible. I mean, I don't have the best use case for it, and I know I'm kind of building stuff that I may or may not need. So we'll see. Never done it before, so it might hurt a little. So there were a couple different ways I tried to implement obstacle avoidance. The first was Craig Reynolds' steering algorithm. The problem with that algorithm is it's meant to be used with circular colliders or circular shapes. And even then, you end up with jittery movement sometimes. So yes, it technically works, and the enemy would get around with whatever obstacle they're running into, but you also have problems when you get into a corner. You can't go around L shapes or corners or U's. It doesn't work all that well in those situations. You'll actually find that to be the case with a lot of different obstacle avoidance or collision avoidance type methodologies, as they work better in some instances versus others. So after that didn't work, I went down a rabbit hole of trying to cover a bunch of different corner cases. I knew when I was getting into it that it was the wrong decision to make. And I literally paused and I thought to myself, I should not be doing this. This is going to be a waste of time. And like, it's just going to make me get all worked up and it's not going to work well. And that's exactly what it did. I didn't listen to myself. I still tried to do it. And I found myself taking a corner case, fixing that corner case, and then breaking like 5 other corner cases. When you see yourself get into that type of situation, stop yourself. Just don't let it go any further. It'll ruin your week, or at least your day. So I thought to myself, hey, none of this is working very well. Why don't I just, instead of being the guy that has to do it his own way, let's use what's built in to Godot itself. And I was like, all right, well, navigation meshes should work pretty well for this, right? Like, that's why they're there. Well, sort of. You'll see when you implement a navigation mesh that sometimes the player takes a suboptimal route, and sometimes they take a route that just makes no sense. I had an instance where the enemy would actually make a V movement just to head in the other direction. And there was, they'd essentially passed their starting point again. I've since found out that the maintainers know about this. They've worked on it. It's actually, I believe the work's actually complete, and it's ready to release for version 4.0 of Godot. The downside is version 4.0 doesn't have a release date. So I spent a lot of time browsing the web trying to find a solution to this. And at the end of the day, I may have found something that might work a little better, maybe. There's a Reddit user, nazgum, who recently posted about his project in the Godot subreddit. And from what I could tell, it looked like he had really good working collision avoidance and all those type of things. Apparently he's been working on his game for like 2 years. So I reached out to him in the comments and I was like, hey, do you know of any good tutorials for how I can solve this? What solutions do you guys use? And he responded that he actually uses steering mixed with raycasting to determine how to avoid obstacles. And then he also uses breadcrumbs dropped by the player to help direct the enemy along to chase the player, which I thought was a cool idea and something I hadn't considered before. He also pointed out that there is a new framework made by the GD Quest team that'll help you implement these different steering algorithms into your code. So this leaves us with, what do I do to avoid collisions? And the honest answer is I'm not quite sure. The solutions I've tried haven't worked. There are other games that just completely ignore it or work around it. I sat down and I think I figured out a solution. This week is over, so that's a problem for next week.
Oh God, I've pissed you off today, haven't I?
We'll see you guys later.
Oh boy, here we go.